So first, I'm pretty sure everybody here heard about 6 gigahertz. It's been all the buzz, but I wanted to give you some reference on where this is going and where it's heading to. It's been one of the fastest ratified standards from a regulatory perspective ever, and it brings an amazing capability to wireless and Wi-Fi. For reference, we got 1200 megahertz in the United States. And there's a lot of rules around that. I'm going to touch on each of them. But 1200 megahertz of spectrum for Wi-Fi is huge. We had cobbled together about 535 megahertz, and there was breaks in it. This is contiguous spectrum, which makes a difference in channel assignments and how efficient we can use it. Etsy is the other model out there. SEP, they're offering 500 megahertz primarily in Uni 5, and I think that's a starting point for them. The basic thing is it's open. It is a wide open frequency. I had a spectrum shot in here of 5 gigahertz and what that looks like now versus then. And I think I had a hospital in 2009 that still literally had nothing happening in 5 gigahertz. And that's a very different story today. With Wi-Fi 6E, we got multiple device classes. There are limitations in power. US is the only one so far who is ratified using standard power, which is required for outdoor operation or indoor operation is permitted. No antenna restrictions. This is basically the pro level, and it's going to be restricted to Uni 5 and Uni 7, which avoids current incumbents which are living in Uni 6 and Uni 8. What we are implementing right now is low power indoor APs. They're indoor only integrated antennas. It can use the full 500 or 1200 megahertz, so there's no restrictions on that. Very low power APs, Etsy and SEP models, some of them are validating and opening up very low power. The US is still considering it. And then the client devices. Just to give you an idea of where the power levels are and where the offsets are. The power levels were done in power spectral density, which gives me a limit of power on a per megahertz basis. In the US, that was a good thing. It actually encourages using bonded channels. And it may, on the surface, looking at the PSD values, look like SEPT in the UK got more than we did. But note that they still have a max limit for maximum EIRP without offsets. Again, FCC is looking at very low power, hasn't touched on it yet. The final thing we're going to need for automatic frequency coordination, or the AFC, is an AFC, and we're releasing standard power AP. Cisco's been very, very involved with AFC coordination and creation. And basically, if you're going to operate at standard power outdoors, you have to be part of a database that gives you frequency clearance and power levels that you can use, and this is all about protecting the incumbents. So with 1200 megahertz of spectrum, we've got a lot of spectrum that we've got to go find resources in. So one of the things that we've spent a great deal of time on, both us and our ecosystem partners, is how do we do that? How do we make clients interested in 6 gigahertz so that we can get them the very best Wi-Fi experience possible? And there are several mechanisms that I'm just going to touch on briefly here that both Cisco and Cisco Meraki are supporting. First off, out of band. That's going to be signaling in 2.4 and 5 gigahertz. In-band methods, there's multiples, and we're going to touch on each of them here. So from an out-of-band standpoint, it makes the most sense, to us anyway, to broadcast in 2.4 and 5 gigahertz where the clients reside today. And we can do this by actually inserting in a reduced neighbor report the 6 gigahertz co-located radio. So in that way, we can make clients that may be currently connected on 2.4 or 5 gigahertz aware of the 6 gigahertz resource. We have been using 11V for quite a while. That's the mechanism that will be used to help steer clients from 2.4 and 5 gigahertz into 6 gigahertz. And so far, this has been an amazing success. We just ran, 21 of the new 9136s at Mobile World Congress the week before last. In fact, lit the whole booth. And I can tell you, in a hall full of 5 gigahertz, having some 6 gigahertz to connect to was really pleasant. It was the only space that was not fully interfered with yet. The in-band methods are many, and they focus on efficiency, and some of the things that we've learned from Wi-Fi in the past as far as spectral efficiency are definitely being applied in Wi-Fi 6E. Multiple BSSID, we're going to be able to link multiple SSIDs into a single header frame. This is not, or a single beacon. This isn't new. It's been around since 802.11v. It is mandated in Wi-Fi 6E, which is sometimes what we have to do to get good ideas used, but it's there, and a sample of the packets. Another method that will be used in band is fills, fast initial link setup. Basically, this sends out it's a reduced beacon, but it sends out all the information necessary for a client to discover and join a cell every 20 milliseconds. So if a client is scanning PSC channels, which we'll get to, 20 milliseconds is its dwell time. So that's all geared towards helping the client make better and faster decisions. I included a packet capture of this just for reference later. Unsolicited broadcast probe response. This is similar to fills in that it is broadcasting every 20 milliseconds. But the idea here is we're going to send a broadcast probe response that's going to allow the client then to make a decision on what resources it wants to join. Again, this contains all of the information the client needs to go ahead and join that cell. Packet capture on that as well. Now the preferred scanning channels. With 59 channels, 20 megahertz channels to scan, it shouldn't be a surprise to anybody that this adds a lot of overhead to our current information gathering on a network. So it's completely out of the question to use the old brute force scanning methods. In fact, a lot of this is not legal in Wi-Fi 6E, and I'll touch that in a minute. To rectify that, they created the preferred scanning list. So preferred scan channels are the primary channels for 40 and 80 megahertz frames. And in the channel, they actually designate an 80 megahertz frame. So everything wraps around that preferred scanning channel, and it gives the client the opportunity to just use 15 channels to actually scan and find resources. Now, this is important because there are some modifications in what a client can and can't do as far as probes in 6E. And I remember years ago in 2.4 gigahertz, back in a stadium where we shut all the Wi-Fi off, and we watched close to 12 or 13% duty cycle for clients looking for Wi-Fi. So it's a big deal. It can cut into it. The protocols have gotten better. But you can't do blind probing in Wi-Fi 6E. You can't use a wildcard. You have to know where the resource is. Clients have to wait a minimum of 20 milliseconds. Nobody says they have to keep it to 20 milliseconds. And clients can send probes only on PSC channels, but non-PSC channels can be used if they know that the resource is there. What do we think is going to happen? Well, what we've seen happen so far is everything has been co-located. Out-of-band discovery has been the primary focus. It's working great. We've tested fills and UBPR with several partners, but it's the most likely deployment. And in 6 gigahertz only, in-band signaling, I think that's going to come with time and more adoption.
So we're talking specifically about Wi-Fi 6E here, which is only the implementation of 802.11ax on a 6 gigahertz radio.
Correct.
This does not apply to anything in 2.4 and 5.
It does not.
So the question that I have is, because some of these things, like the BSSID thing, would be wonderful if we could do it in other more congested frequencies. Are these things that people are looking at introducing in, what are they calling it now, Wi-Fi 6 Release 2? Or is this going to be kind of a ships in the night thing until we eventually get to Wi-Fi 7?
I think this is going to be ships in the night thing until we get to Wi-Fi 7. The legacy component of the current Wi-Fi makes a lot of these things difficult. And as you know, even implementing 11V or WPA3 is met with challenge on a lot of sites because of the amount of legacy devices that they contain.
So to that point, do you see people doing a little bit more, I don't know, investment of development in the 6 gigahertz side of the spectrum because it's kind of an open field that they can play in, and are going to kind of relegate 2, 4, and 5 to be more of a like a legacy band where we'll just do the minimum we need to be able to get people working, and you can use it if you want, but boy, wouldn't it be great if you could use this other one?
I anticipate, and that's where we got to with 5 gigahertz, was that is the performance bet. And if you want to use 2.4, go ahead, but I see that shifting to 6 gigahertz in time. And that's why I say the highway's open now. We'll fill it. Bandwidth is like money. If you have it, you spend it, right?
Yeah. Thanks, Jim.
Okay. Yeah, I'm going to move real quickly now. WPA3 security is also required in Wi-Fi 6E, and that also gives you some interesting challenges as far as implementation today with current networks that need to be thought about. We're supporting everything that I just talked about: broadcast probe, Phil's discovery. It's a client's choice. The multi-BSSID profile can be applied to put all of that into one beacon. We are biasing towards PSC channels in RRM. You can enforce it, which is the default. If you take it off, we are still going to look to use PSC channels and bias that direction unless there's a good reason not to. So that brings us to the Wi-Fi 6E product line. We just recently released the Catalyst 9136 series, and that caps the Catalyst line, which runs from the 9105 all the way past the enterprise grade 9130 to now the 9136. In short order, the spec sheet on this is a full enterprise class AP. It's got a 4x4 radio on 2.4, 8x8 radio on 5 gigahertz. We preserve the option to do dual 5 gigahertz for folks that may not have 6 gigahertz yet, or like dual 5 gigahertz and want to run 6 gigahertz as well. 4x4 radio and 6 gigahertz. We have a dedicated AI ML scanning radio, which we've designated as Clean Air Pro, and 2.4 gigahertz IoT radio. Dual PoE, and I'm going to touch on that a little deeper later. I want to point out that these radios are very capable in 5 and 6 gigahertz, 37 RUs up and down OFDMA and MU MIMO. And I can tell you there was some concern about 8 spatial streams, but I've got lab results that show 8 spatial streams and MU MIMO working fantastically, and it just walks away from everything else.
I didn't see Mobility Express on that last slide. Is that on the roadmap?
You did not. It is not. Right now there is implemented a site survey mode that allows you to bring that up and operate it for site surveys and things of that concern. But Mobility Express or embedded controller is not on the roadmap for this AP right now.
Gotcha. Thank you.
Mm-hmm. A couple of changes to the physical appearance of the AP and the mechanical design. Of course, we added another radio, so that is more. But the radome shape has changed, and we have enlarged the important area where you have to connect power and do all the things you do with the ports. That has been a sore spot for some time. We fixed it. Ports on the AP, we've got 2 5 gigahertz M-Gig ports. We've got console port, we've got the reset button, and then we have added the environmental sensors, which is going to play into a few things that we've got coming up now. And all of that, by the way, is sealed, so we did not add any vents or open holes to the cabinet for the environmental sensors. I remember that conversation. The dual M-Gig ports can be used either as link aggregation or dual redundant PoE.
I'm curious on the dual ports. We've had some customers, as we started, showing them the 9136, asking if they could just, add a, 9300X switch to a stack to provide the primary port, and then use a traditional 1 gig for the resiliency, knowing, of course, obviously that there would be, slowness in the event of a failover.
Yeah.
But they're trying to save a little bit of money, at least up front, until they can totally redo their stacks.
Yeah.
Is that a supported configuration?
I don't have a good answer to that question. I've actually just worked with the lag on 2 commensurate switches, but it's a very good question, and I'll get you an answer.
Okay, I appreciate it. Thank you.
Okay. All right, weight and size commensurate with the other Catalyst line. They keep getting more capable and they keep getting smaller. Power is the other consideration. 47.3 watts to run all the radios. It doesn't come for free to have radios. But we can back up. We can use AT power. It's a very capable radio at AT power. And then we also have 802.3 AF support. This brings up a single Ethernet on 1 gig, but it gives you the ability to go ahead and pre-stage these and move them out if you don't have those kinds of resources where you're doing that. Clean Air Pro, very important part of this. Short story on this. Clean Air was designed for 2.4 and 5 gigahertz. The RF ASIC, while amazing, was not going to scale well with another 1200 megahertz of spectrum, so that had to be rethought. That leads us to the new scanning radio, and a lot of things that we've always wanted are being slated for development in here. Right now, at the time of release, I do have 6E packet capture through ICAP. I do have WIDS, WIPs, and rogue detection on the radio. The next release, 17.8, is going to add in spectrum analysis, again in ICAP. 6 gigahertz RRM elements, meaning off-channel scanning, and a lot of that functionality along with fast locate. And then in 17.9 is when we get back to doing interference identifications and the classifiers, which Clean Air has always been so famous and stood alone for. So these things are on, and I've actually seen demonstrations all the way out to 17.9, and I don't mean the script kind of demonstration. I mean actually functioning and working. Already integrated into the next release of DNAC, Wi-Fi 6 dashboard is extended to include 6E. Short story on that, I call this the boss button. Tells me how many clients of a certain kind I have with anything that is 802.11 AC Wave 2 or later. We can detect Wi-Fi 6 and 6E. Tells you the network readiness, how many of those clients you have, where they're connecting to, and then it also gives you some speed and efficiency comparisons, measuring total traffic over time. We also have spectrum display in ICAP spectrum. This is now being broken down into 4 unis because 1200 megahertz is a lot to look at for anybody. Intelligent capture support, in fact, all of the data captures that you saw today we're already doing off of DNAC. And then rogue management WIPs on Wi-Fi 6E. What's in Wi-Fi 6E or 6 gigahertz space that we need to worry about? Nobody knows yet. But we have the ability to actually track it today, locate it, and do the things that we do with WIPs and WIBs.
One thing that I know that was brought up in the 6 gigahertz space, which is kind of contentious, is things like satellite downlinks and fixed emplacement stuff.
Yes.
I know that in the past, rogue management has had an element of containment that can be a problem. Has that algorithm been adjusted to just be kind of an alerting thing where you can say, okay, let's just avoid it so we're not accidentally, I don't know, bringing down a keyhole bird or something like that? Or is it more of a, like, we're just applying the same lessons that we had before and good luck with things, just don't get caught by the FCC?
Well, no. I mean, it's obviously been adjusted for 6 gigahertz, right? And remember that rogue containment has to actually identify a Wi-Fi resource. So I don't believe that's going to get confused with one of the out-of-band signals. And interesting you brought that up. The incumbents, very, very serious business with the incumbents, right? There's a lot of things I expect is going to loosen up once we get out there and deploy. But right now, the FCC is hyper vigilant about the rules. So we are also hyper vigilant about the rules.
I'm Steve Rodriguez, technical marketing engineer for Meraki on the MR product lines. As we step through and go look at where we're at with the MR57, this might look a little bit familiar to you if you were paying attention about 3 minutes ago. The MR57 that Meraki is putting out looks very much like the 9136, to the point that on the right-hand side here, we are finally adapting to using the same T-rail adapters and mounting brackets that Cisco is using. So as you're going through upgrading and migrating away, it just became a lot easier. Some of our radio feature highlights that we have here is we've moved from our mechanical design. Instead of being a hexa radio, we're a penta radio design. We have a 2.4, 5, 6, our IoT radio, and of course our scanning radio that are out there. From a mechanical design aspect, we've moved that LED from being on the side where it was very, very difficult to see and make use of, to the front where now if you go through and start flashing LEDs, you're going to be able to find it very easily. Much like the 9136, we have a much wider bay for being able to get your cables in there, because if you've ever tried to plug a Cat 6 or Cat 6A cable in, they don't bend very well, and now you have a nice broad area to slide those in and get those connected with. If we look over here, continuing on, we still have AC power adapters. We have dual 5 gig capable ports that'll take PoE, PoE Plus, and UPoE to support the AP. And new for Meraki on our MR57 is we have USB support that will provide up to 9.5 watts of power. So if you were using an IoT dongle like a ESL adapter from Hansho or Sol UM, you're able to plug that in and run that, power it from the AP and connect it back to their clouds. As we go through and we keep talking about our scanning radios, it is a tri-band scanning radio. So we will scan across the 2.4, the 5, and the 6 gigahertz as we're looking for what's out there in the spectrum. We still do our location for Wi-Fi and BLE. Going to kind of skip one thing, come right back to it. We still support air marshal. So you can still do WIDs and WIPs and containment only on the 2.4 and 5 gigahertz spectrums. This is because with on the 6 gigahertz spectrum, PMF, protected management frames, is a requirement, which means that all the frames that we would normally use to be able to de-auth a client that was on a rogue access point are invalid and would not be decrypted by the client. So you're going to have to do a little bit more work when you're trying to do containment on 6E to make sure that you don't have something in your network that's not supposed to be there. We do have a spectrum analyzer built in as well, typically like you would see for our 2.4 and 5. It will not be in the dashboard at FCS, but will be coming up shortly thereafter. We just need to make sure that we have all of our graphics designed properly to show, all 1200 megahertz of this frequency that we're gaining. Moving on to power considerations, if we look at an older, really old switch with a single 802.3 AF port or 15.4 watts of power, unlike the 9136 that will power up, we will not power up. We will stay down. Looking at moving forward, 802.3 AT power or PoE Plus will give you support for all 3 radios at their maximum transmit of 4x4. The only thing we lose on AT power is there's no USB. And of course, if you're running 802.3 BT, you get full support. All 3 radios and the USB port are up and functioning. Next, we kind of have a little bit of an eye chart, but this kind of does lay it out a little bit better and has a hidden surprise. If you have PoE, 802.3 AF ports, if you can provide 2, we will power up as an AT, as it were if you were doing 802.3 AT. So you'll have 4x4 on all radios, you just won't have the USB support available. It is worth to note that to my knowledge, the MR57 is the only 6E access point that operates at full 4x4 across all 3 radios on AT power. Every other vendor seems to have a little bit of a reduced mode where they're either bringing down to 2x2 or maybe they're turning off one of the radios. So do kind of like that.
I'm not a wireless guy, so this may be obvious to others and not to me, but what's the purpose of, like, what does the USB do on an access point? What would that be for? I know it's probably not what you wanted to talk about in this presentation. It's just more my curiosity.
No problem. It would be for an IoT device. So one of the things that we do, like natively, we work with SES and MagoTag, and we run a container on our access point that supports their the link to their cloud to support the electronic shelf labels. For a couple other vendors, Hansho and Sol UM, we need a dongle. So you have a USB port it's a USB card that has a couple of antennas on it to broadcast in their frequency. So you would plug this into there to power up and offer those services. Those are the 2 applications that we have going right now that we're currently working on. But as more and more customers and vendors want to work with this, we have the ability to work with them as long as they can provide us a USB piece to power up. Again, as we said, we have dual 5 gigabit Ethernet ports. These, much like the 9136, these will work either in a LACP mode, or you can do PoE redundancy mode. This is pretty nice if you have dual 802.3 AT power coming in, right? You will operate that AP like it's BT, so everything works. If you lose one link, everything stays running except for the USB port. So if you were doing something on the USB port and it suddenly went away, looking at our Ethernet ports here would be one of the first things I would go and take a look at. There has been questions on what does coverage pattern look like. So these are coming out of our hardware test team with 6 gigahertz and that LPI, that low power indoor mode. Because we can gain 3 dB for every time we go wider on the channel from 20 to 40, 40 to 80, we're able to maintain our RF radiation patterns across. So if you look at the 5 gigahertz frequencies at a set power of 23 dBm, that's what those antenna patterns look like, or the RF patterns look like. On 6 gigahertz, we maintain that. So what's really important to take away from this slide is you should be able to do a one-to-one replacement. If you take down an access point that's 802.11ac or Wi-Fi 5 and put up a Wi-Fi 6E AP, you should have comparable signals and comparable coverage all the way across. Now, the fun last little bit here is there are a lot of acronyms that we heard, right? We have PSC, RNR, UBPR, fills. With Meraki, like part of our DNA is keep it simple. All of these things are taken care of for you. All you need to do is believe in that Meraki magic, plug in your AP, and this stuff's going to work for you.